Hey, let's try lesson 5. We're now talking about triangles and circles. So last lesson we talked about triangles and quadrilaterals. No, we talked about circles and quadrilaterals. And now we're talking about triangles and circles. Circles and quadrilaterals, now circles and triangles. Let's keep it straight. All right, so our student task statement. The image shows a triangle, 3 sides. Construct the perpendicular bisector of segment AB. Now, if you remember, that's where we take the pointy end of our compass, right there, maybe, the pointy end of our compass, and we make an arc. Pointy end, arc. And then we put, pointy end here. Don't change the diameter, don't change the opening of your compass. And I'm having pen issues. It's quite annoying. And where this intersects, we draw a line through. Okay? That means that our arc needed to go like this. So where the two arcs intersect, we draw a line through, and that is a perpendicular bisector. Okay, I'm going to erase some construction lines, hopefully. So we got that. Now, imagine a point D placed anywhere on the perpendicular bisector you constructed. How would the distance from D to A compare to the distance from D to B? They should be equal. Okay, any point on the perpendicular bisector is equidistant from the endpoints of the segment we bisected. Okay, any point. These little green lines I'm drawing are all equidistant from A and B. Okay, I could put tick marks, double tick marks, triple tick marks, quadruple tick marks, etc. Okay, we learned that a while ago. So any segment, if I draw the perpendicular bisector, distance from here to here is equal. Like these are equal, those are equal, as long as your point is on the perpendicular bisector. Okay, those are all equal. Pen problems, quite annoying. I think my computer's tired, needs a break. All right, so here we have perpendicular. I actually don't know that. I'm not sure what this drawing's for. Let me go look. All right, this is silly. So this dotted line actually represents the perpendicular bisector of AB. So perpendicular bisector. Now, point G, is it closer to B or A? Closer to B, because it's on that side of the perpendicular bisector, okay? It's like the thing that divides land in half. Okay, if you're on one side of the fence, you're closer to the whatever. If you're on the other side of the fence, you're closer to the other. C is also closer to B because it's on that side of the fence. F, on the other hand, is closer to A because it's on the other side of the fence. Yep, rocket science. Just kidding. All right, so let's look at these perpendicular bisectors. Okay, I think there might be a GeoGebra activity. All right, I'm making my own GeoGebra applet. So here is the triangle, and there is my triangle. Okay, I'm going to keep on having to click back and forth, and it's okay. So construct the perpendicular bisector of segment BC from the earlier activity. Label the point where the two perpendicular bisectors intersect as P. So I need to do the perpendicular bisector of AB and BC. So I need more tools. Perpendicular bisector. So click, click, there it is. Click, click, there it is. Now I want to find the intersection, which I think is under the point tool. More. I always have a hard time finding that intersection one, don't I? Construct, no, measure, points, intersection. So I want to intersect this and that, and I don't remember what it wanted me to name it. So I'm going to move my head a little. It says to name the perpendicular bisectors as point P. So let's point P. Cool. All right, what's the next step? Use a colored pencil to draw segments PA, PB, PC. How do the lengths of these segments compare? So I want PA, PB, and PC. PA, PB, and PC. How do these compare? Well, let's measure them. Distance or length. Select 2 points, a segment, a polygon, or a circle. 4.5. 4.5. 4.5. Guess what we found? We found the center. We found the center. I know you're as excited as I am. How do the lengths of these segments compare? They're equal. Explain your reasoning. I measured them. Imagine the perpendicular bisector of segment AC. Will it pass through the point P? Okay, let's look at it. AC. Will it pass through point P? Yes, because, let me get this drawing tool out. I know we don't like this drawing tool. But if we draw the perpendicular bisector, it goes through point P, because this segment and this segment are equal. And point P is on the perpendicular bisector because it's equidistant from A and C. Okay? It's equidistant from A and C. That means that it's on the perpendicular bisector. I wish those drawings stayed there longer, but they don't. Let's check. Perpendicular bisector. It's there. Wow. I just watched the movie Moana last night, 2 nights ago, and the crowd goes wild. Yeah, stop laughing at me. I've had too much coffee. Construct a perpendicular bisector of segment AC. Check. Construct a circle centered at P with radius PA. Circle. Circle with center P and radius PA. Oh my gosh, it goes through B and C too. That's amazing. Why does a circle also pass through points B and C? Because the distance from PA, which is how I constructed the circle, is the same as the distance from PB and PC. Those are all radii of the circle. Therefore, it goes through, all those points go through the circle. Woohoo! We did it. All right. Oh, of course, now we get an applet. So move the vertices of triangles ABC and observe the resulting location of the triangle circumcenter, point D. So it's called the circumcenter. We didn't talk about that. Point P is called the circumcenter. Write that down. Circumcenter. So D, we assume point D, that's going to be where all the perpendicular bisectors meet. So it's the circumcenter. So if we move, okay, if we make point B, if we make angle B obtuse, D is on the outside of the triangle. If we make angle D acute, little angle, there, definitely acute, D is on the inside of the triangle. So I've got obtuse, acute, what's my third possibility? Right. If B is a right angle, D is on the opposite, it's on the hypotenuse, okay? It's on one of the triangle sides. So outside the triangle, on one side, and inside the triangle. Okay? On the triangle, outside the triangle, yeah, I think after this lesson I'm going to have to make my computer take a break because it's not happy. There we go. Okay, when this is acute, when this is obtuse, and when this is right. It's terrible. Okay. Cool. So that's a lot of fun. And you have access to this in your curriculum. And that's it. That's our summary. All right. Good job. Here's some vocabulary words that you need to make sure you remember and what we can add to our glossary. Okay? All right. Good job today.